Okay, welcome everybody. How's milestone 1 going? So you've already started. You had your first lab period, I think, on it already. For everybody who's in this tutorial, going fine. Okay, so you're gonna learn more about milestone 1 here. So maybe I'll ask you the same question at the end. Okay, so we're gonna talk. This is a walkthrough of how to attack milestone 1, in particular one function. We're gonna at the end of this, if you can transcribe code, you have one function done. You're gonna pass all the tests. And you can apply those techniques to the other functions. Okay, so milestone 1, I talked about this in a lecture, but let me quickly review. You're basically building, you're building on top of this streets database library. Does everybody know what is a library? Do you guys know what a library is in computer programming? What does it mean? So I said there's a streets database library here. What does that actually mean? You guys know? Okay, so maybe nobody knows. A library is a collection of object files. So, I mean, you take source files that you group together to produce some useful function, but then you compile them into object files, so .o files, and then you can run another tool that basically takes those .o files and puts them together in something called a library, okay, that you can now call. So it's compiled code. You cannot modify this. We wrote it for you. It interacts with the low-level OpenStreetMap data. But we give you a header file that tells you here are the functions that exist that we expose, so you use that to talk to it. Your main executable, so the C++ program always starts in the main function. So there's a main.cpp in the project that you have once you initialize milestone 1. And in that main executable, you can call load map and you can call close map. To set up the data, okay? We do not really care about this main executable for this milestone. What we care about is the code that implements the functions we tell you to write in m1.h. And that code, the way we set up the makefile, is actually compiled into another library, okay? So that just means a bunch of .o files then get grouped together into something that actually will end in .a, and that means it's a library. So a library is one step short of a full program. So by combining it with a little bit of code in the main directory, you can make an entire program. But we don't care about that program for this milestone. What we care about for this milestone is we've written tests that can also connect into your library to produce a complete program. And those tests are what we care about. We want them to pass. They're also going to call load map. They're also going to call close map. And they're going to call a bunch of other functions that we define in the header file that you have to implement. Okay, does that make sense? The reason I'm telling you this is if you go off, well, you'll find inside, let's see. So you'll find inside let me remember where this is. Yeah. Okay, you're going to find that inside the repo that we've given you, there's basically a subdirectory called main/source. You don't want to do anything in there. I mean, you can do something if you want, but it's not going to go into this library, so it's not going to help you with milestone 1. What you want to work on is there's another directory called libstreetmap/source, and that is the code that goes into this library. And that's the code we're going to test. So that's where you want to write all your M1 functions. Does that make sense? You can reuse these functions later on, right? You can have a main program that also calls them, and then later milestones will do some of that. Okay, so our tester executable is going to call your load map. It's going to do a whole bunch of calls to your API functions to make sure they work and are fast enough. And then it's going to call your close map. For you to be able to answer these queries, you are going to have to ask questions of the library that we've given you. You're going to have to load its data. You have to ask it questions. You're going to close its data when you're done. All clear so far? Sounds good. Okay. Okay, so what do? How many people read the handout? Quite a few. That's good. Yeah, you have to read the handout. Okay, we're asking you to implement an API. It's going to use libraries. There's some complexity to it. Just going, hey, maybe I can go in the lab and just ask my friends and the TAs. It's not going to work. Okay, so read the handout. You will need at least one global variable. And I talked about this in the lecture. You will not be able to make all the functions we're asking you to make. You won't be able to make them all fast enough, particularly the high performance ones. So those with performance requirement high, you're going to need to store some data in load map, and the only way to get that data to the functions that we're going to call the tester API is through a global variable. So you need at least one. And we taught you STL for a reason, right? So if you're going, hey, why are we learning all this stuff? Now is why you're learning it. You're going to use the container classes from STL because we're telling you need to store some data. You don't have time, and it's not best programming practice to go off and just write low-level data structures yourself. You should use the STL, right? You figure out what would be the right way to store this data, use the STL, write the code in load map. Often the code won't be very long. STL actually helps you make the code much, much shorter. What's in those container classes? Well, we've gone through them, right? There's vectors, there are lists, there's maps, unordered maps, and a few variations on that theme, like multi-maps. So a lot of your decisions in this milestone, when it comes to the high-performance functions, are going to be what's a good data structure for this. We'll talk a bit about that at the end of this tutorial. And once you've chosen the data structure, the nice thing about the STLs is pretty fast to get it, right? You just ask for it. Okay, so I mentioned this in lecture, but we talked about how are we going to model all this data about a city. And a lot of the key data is going to be modeled as a graph. Okay, so we have this notion of street segments. Each of them has an ID, represent a city block, and we have intersections. Those are the two most important things in that libstreetmap library that we give you. Because, well, it's kind of the heart of the city. If you know where the streets and intersections are, you can get around. It also helps you draw a lot of it. Okay, so what are you given? So you are given a little skeleton code to get you going. So you're going to have to include m1.h. That's the header file of the functions that you're supposed to implement. You can't modify it because we made it read-only, and that's on purpose. If you were to modify it, you would never pass the tests, right? The tests assume this interface. You're going to include actually both of the APIs we give you. So streets database API.h, and we also give you a lower level one, OSM database API.h. You're going to include both of those. And you're going to have a load map function and a close map function. And the simplest thing that your load map function could do is it has to at least load our low-level data structures, right? If you don't load our data, you can't do anything. So you at least got to do that. And your close map has to at least, free our data structures by calling the right function. Okay, so what should you do to attack M1? So you run ece297 init1, sets up your remote repo, your local repo, your working directory files, connects your whole team together. You compile your code. So we put some skeleton code into your repo already. So you compile it to see what does this do. And you run our tests. And to run our tests, you run ece297 exercise and you tell it which milestone. So milestone 1. Okay, so you do that. How many people have already done this? It's like, I already know what happens. So what happened when you did that? Do you remember? Yeah. You got failures all over the place. So yeah, you do that, you're going to get this. So you're going to compile. You won't even be able to run. So you can't get to that. You're going to get a whole bunch of compiler errors. Okay, so hopefully you can read this, but basically it's a path to, basically it's a long path to our tests. So this file here is M1 functional test intersections in Toronto public. Okay, so the public test related to intersections. It's a C++ file, and it's saying on line 185 of that, well, what does it say? It's saying something about line 185. What does this error mean? It says undefined reference to find street segment length of integer. What does this error mean? Yeah, function doesn't exist. Okay, so we wrote test code that is trying to call this function. And if you look inside this file, and you can, so you can just go there and open it up and look at our tests, you'll see the reason to get all these lines is every one of those is calling this function. And we're basically checking if it works, right? We're calling it with various intersections, and we're seeing if you return the right value. But you can't even compile because you get this error. LD is the linker. The last stage of compilation is called linking. Linking ties all the object files together. So you're learning in 243. In 243, you've learned, I believe, how to call a subroutine. Is that correct? Right? So you know that to call a subroutine, you actually branch or jump to a certain memory address. So what the linker does is it actually puts all the memory addresses in, right? You said you want to call this function. I put the memory address into the object code of where that function is. Jump to that address. When the linker fails like this, it's basically saying, you said call this function, I can't find it in any of these object files. So I can't figure out an address. I don't know where to jump to. So, and it basically says, like, I can't do this. Okay, so how do we fix this? What do we do? It's not a trick question. You're like, well, it isn't, if you think, oh, this is obvious, it is obvious. What do you think? Well, it's obvious once you've had these messages, but the first time you have them, you might not know what to do. So what do I do to fix this compiler error? If you think it's obvious, it's fine. Go for it. What do you think? Write the function. You got to write that function. Okay. Now, so I go look at the header file because I want to know, well, what is this function supposed to do? And let's see which function I said here. All right, find street segment length. So this is the function that it's complaining about. So I need a function that takes a street segment index as its input and returns a length. I think that's the function it asked about. Yeah, okay, returns a double. Remember, street segment index is just an int. So that's why when it said this function doesn't exist, it said this name, taking an int, can't find it. So I got to write this. Now, if I do write this and I compile, what I'm going to get next is I'm going to get actually errors on this one. Okay, it's going to say, well, that one doesn't exist either. And some of our tests are trying to call it. So we told you, you want to be agile. Agile means get something working as fast as possible. So you could say, well, write all the functions, right? Once you write all the functions, it'll be fine. It'll compile. And you're right, it would. But I don't want to wait that long. So I'm going to write this function. But I need my program, my library, and tests to compile, and I want it to happen now, so that I can actually check my function. I don't want to wait to write all of these, then check them all together. How can I make these compile really quickly? What do you think? Yeah. Yeah, so I'm just going to write, I know it's not going to pass the tests, okay? But you told me that I should have a function named find street segment travel time, and it should take a street segment index. Okay. So I'll just say, I'll write a function that says an empty body, right? All it does is return 0. It's going to fail all the tests, but it will now compile. That technique is so common, it actually has a name. It's called stubbing out the functions, because this happens all the time. You've agreed with some other developers. You're going to write functions. Here's the header file. I'm going to call them. We're going to work together. But those functions aren't written yet. And I need to be able to compile to do anything, like to do any testing. So I want you to write just these empty bodies of functions so that at least they'll compile. Okay, so it's called stubbing out the functions, and we're going to do that. Okay, so the function that we're actually going to mostly focus on in this tutorial is this one. Okay, so it's find street segments of intersection. It takes as input one number, the ID of an intersection, and it returns a vector, which are the IDs of all the street segments that connect to that intersection. So it's a little piece of our graph. And there's a little bit of extra information here. So it says the speed requirement for this is high. So we're going to also have to make this fast. Okay, so I already did this, right? We made our stub implementations. Now we can compile, and then we're going to focus on that one function. Okay, so after we made the stub implementations, we run ece297 exercise. We're much happier that it all compiles, but we're going to fail every single test. Okay, so and we divide the tests up into a bunch of test suites. So you're going to see that ece297 exercise gives you this little report. So it says all of the M1 functionality tests related to intersections, we failed 4 out of 4. And all of the performance tests related to intersections, well, we failed 4 out of 4 there too. We actually failed absolutely everything. And that shouldn't surprise us, because all we did was write functions that just return the simplest thing we could. So we wouldn't expect that to work, but at least now we can compile and we can see the failures. So that's good. So the way we're testing this is with something called unit tests that you're going to learn about in lecture next week. The philosophy of unit tests is if everything works, you say nothing. Okay, so we don't print any error message. We don't print any messages when things work. We only print messages when they fail. And then we give you a summary. Okay, so we'll give you a summary saying everything passed or this many things failed, but don't expect much output if you pass, because that's generally the convention in testing. No news is good news. Although you should give a summary, like at the end you say all tests pass. Okay, so got things compiling, I've got errors. Oh, and by the way, all of our all of our scripts, all of our tools for this course take a -h argument. So if you want to know, are there any other ways I can run ece297 exercise? There are, and you can see what they are with the -h option. In particular, you can tell it to only run certain tests. So if you go, look, I'm only working on one function. I know all the other ones are going to fail. I don't want to like have you tell me over and over again. It is bothering me. It's causing me psychological trauma, or I just don't want to wait around for it. You can, with this option, you'll be told here are the various options you can give to ece297 exercise, and one of those is only run certain tests. So if you want to, you can tell it just run certain things, because that's what I'm focused on. Okay, so this is the first function we want to write, though. So I already mentioned it. Takes an integer that is an intersection ID. Its name is find street segments of intersection. So we use very descriptive names. And as I said, it returns a vector, also of integers, but these ones should be the IDs of street segments, all the ones that connect to that intersection ID. So a little bit of code I can write right away. I know I'm supposed to return a vector, so I'm just going to declare a vector, and I'm going to call it SSIDs. Again, these are type defs, so street segment index is just a synonym for int, but it helps me keep track of what kinds of things am I trying to put into this vector. I also know that at the very end of the routine, I better return that. Okay, so I got my first two lines of this routine. Now I need to actually figure out how to fill in this vector. And it's pretty clear I need something. I need to look at some information that's outside the scope of this function. The only thing this function has passed into it is a single integer. So there's no possible way I can just look at that integer and figure out what is the answer. Got to look at some other information. And that other information is going to be given to you by that streets database API header file. Right? That's your menu of what questions can I ask. So there are two functions in this milestone where you're going to need to use the OSM database API. All the other ones, you only need to use this header file. So that's the one you use most of the time. Yeah.
Header file. I wanted to like a text, have an EPF on my IDs that I can go and look quickly what the function, what it does, what it returns with. With that in the source.
It's in the source. Okay. So it's not put in your repo because that would be bad practice because we don't want you changing it. Okay. But the reason we gave you these skeleton files is you notice the skeleton file we gave you actually includes this header file. You don't have to do this, but if you actually look inside of our make file sets up a search path, which means that your IDE will find this header file. So if you go on that line in your code, and you actually click, it depends on your IDE, but it's usually like control click or F12 to go to basically browse to that file, it'll open that file up and you can look at it. If you are typing in your IDE, and most IDEs have a way they will automatically start guessing what function you're typing. Your IDE will know about our functions because we put them in this header file. It will actually show you, it looks like it might be this name. Does that make sense? And it'll tell you what its inputs are. So your IDE will help you, okay? So you can, what is it in VS Code to browse into a file? Is it F12 or control click or what? Slightly different in every IDE, so I can't remember the hotkeys in all of them. Okay, so you can right click and go to definition. That'll work too, it's less mysterious. So you can go in there and you can read it. Okay, and as you're typing, if you get the first few characters right, it'll start showing you here are your options. Does that make sense? And again, every IDE does this slightly differently. Most will start showing you options as you're typing. If not, there's always like a, right click and say, show me like functions that might map. Okay, so you're going to need to go look in Streets database. And the first function you write, you're going to go, okay, I don't know what to do. I'm going to have to read this whole header file. The header file's not that long, right? It's probably, we printed it out in instructions and it probably takes 2 or 3 pages, but it's extremely heavily commented. So the reason it takes 2 or 3 pages is that it's telling you a lot about how does all this stuff work. There aren't that many functions. There might be 15 functions in there. So what I'm going to show you some of the relevant things inside this header file, though. So inside this header file, there's a struct called street segment info. And inside that struct, it basically gathers together data that you can get for any street segment. And the information that you don't need all this information for this function, but some of this information can be useful. So every street segment knows the 2 intersections at its 2 ends. It's got a from and it's got a to, okay? So that's what this is, 2 different nodes. They both have IDs, and the street segment I'm thinking of is right here. It has a Boolean value one way. If this is a one-way street, so if that's true, then you can only go from to 2. If the bool is false, then you can go either way. And in that case, from and to don't really have any special meaning, right? They're just like intersection 1 and intersection 2. But if one way is set to true, then you can only go from to 2. I talked about this in lecture. Curve points is basically if it's curved, this will tell you this street is not straight, and you can go ask questions about what are the points that define its outline. It also has a speed limit, and it also has the ID of the street it came from. So this is everything we know about street segments. We also have other functions that let us ask a few more questions that are useful for this, this problem. Okay, so there's one in there called get num intersection street segment. Okay, so the names are pretty long, but read all the way to the end. You pass in an intersection ID and you get an integer. Okay, so it's just telling you this intersection has, like a typical intersection has, 2 streets meeting, which means there's like 4 street segments meeting. So for that typical intersection, this would return 4. Does that make sense? If you've got a weird intersection where maybe 1 street ends, then you might return 3, because there are only like 3 pieces of road that meet in this intersection. If you get some bizarre intersection like Times Square or something, you might get 7, because it's just all the roads come together. Nobody knows what to do. All the people honk at each other. Okay, but that's what it's going to return. Some small integer that says how many street segments come together at this intersection. Yeah. Yeah. Well, it's a weird. Remember, street segments are like city block pieces. So here's a typical intersection, right? This is College. This is St. George. St. George goes both above and below, like north and south of the intersection. College goes both east and west. Those are all separate street segments. So this is like the most common number you're going to get is going to be 4. But you're going to get all sorts of other ones. You can even get like dead ends where you get 1, right? So I got a dead end. There's actually an intersection at the end of that actually only has 1 street segment. So it's not a super interesting intersection. If you can think of it happening, it will happen in some city. Okay, so as we processed all this OSM data, when we first started, we thought, this will never happen. Somebody built a city that happens in. Okay, so don't make any assumptions of this will never happen. If you could encode it in our APIs, assume it could happen. Yeah. Yeah, so roundabout's a good question. So it depends how essentially how it was embedded, but usually a roundabout is actually multiple street segments like this. So there's a street coming in, a curved street coming in, and a curved street coming out. So this is a piece of a roundabout, and you kind of keep drawing this, and you get like a whole roundabout. So that would be like a little roundabout. This is how they would typically show up in the data. Okay, and I'm not giving you like an absolute rule, but it actually depends how the volunteers who did this, kind of entered the data and then how we process it. This is how roundabouts are normally going to show up. You would actually get, for example, 4 intersections and all these curved and straight street segments, and together they describe the whole traffic circle. Does that make sense? And if you take like one of those crazy, like London is one of the cities that we're actually going to test you on. So in London, there are some pretty wild roundabouts with lots of stuff coming together. That's how, so you have more than this number of segments. But anyway, that's a good question. Okay, so this first one is just going to return a small intersection. This second function kind of goes with it. Okay, so it says get intersection street segment. So what you pass this one are two things. The second argument is the ID of the intersection. Okay, so say the same ID as I had up here, maybe that was ID 180. And this segment number basically goes from 0 to the number of street segments that hit that intersection, -1. So it's just a way for you to ask for, tell me the first thing that hit this intersection or the 0th thing. Tell me the first one, tell me the second one, tell me the third one. You should never ask for the 4th because this should only go from 0 to 3. What I showed you here, there only are 4 street segments that hit that intersection. Okay, so I should only ask questions with this segment number going from 0 to 3. Does that make sense? So just a way to call our API saying, give me the next thing, give me the next thing. Okay, then the last function that's going to be useful to you is get street segment info. Okay, so I showed you street segment info. You can get the struct for a street segment that has some helpful information in it. And the way you get that for a specific street segment is you ask by its number. Okay, so if this particular street segment here was number 235, and I asked for the street segment info of 235, well, I'll get that struct that goes with that piece of roadway. Does that make sense? So this is enough for you to write that M1 function that we talked about. These 3 functions plus knowledge of what's in that struct, that's everything you need. Okay, so let's look at this a little more. Okay, so first, you see our names are pretty long. So we do actually follow a convention to help you remember them. Yeah. Go back? Yeah. Go back one more or what? Oh, okay, so 180 was just, I'm making up a random number for the intersection ID, okay? And 235 was making up a random number for this street segment's ID. What does this last function do? Okay, so I know that I have street segment 235 is the street segment I'm interested in, okay? I called these other functions. It's told me the street segment 235 is like one of the street segments that hits this intersection. I'd now like to know more about street segment 235. If I want to know more about it, I ask, give me the street segment info that goes with street segment 235. Okay, it returns a structure called street segment info. What's in that structure is also defined in the header file. That structure has all these data, all these variables inside, all these member data variables. Does that make sense? So you can use the dot syntax to just access any one of these pieces. It's again good programming practice. We could have had like a bunch of functions, like tell me it's the one way, tell me it's from, tell me it's to. We decided we'll just group all that together in a structure and you can ask for all of it once, because it's usually probably a little more intuitive. So you learned struct probably in 105, is that correct? Yeah. And you know that a struct, well, what is the difference between a struct and a class, C++? Anybody? What do you think? No, struct can have functions too, actually, in C++. So there's not much difference, yeah. Yeah, so the only difference is the struct, everything's public by default. So if I change the class and then put public colon, it's exactly the same from the compiler's point of view. People usually, when everything's going to be public, they call it a struct because everybody kind of knows what they mean, right? So you could just say class and then public. So struct is basically not trying to hide it. It's like, just try, I mean, you could actually make a struct and then say private, but it's just confusing. You kind of like just doing sort of weird things. Normally when you make a struct, you're like, okay, when a group just stays together, I'm not trying to hide it. We don't put axes around us, etc. We're not, it's basically, this is just the way to group data. There's no point in us trying to hide it. Does that make sense? Okay. So I actually, yeah, so let me give you a little more information on how to remember these function names. And you won't remember them all. Okay, I cannot remember all our function names either, but it's made them so long. So I go to the header file all the time. And the comments at the head, I wrote the comments in the header file. I wrote them so that when I forget, I can go read them. But our convention is this. So this function starts with get, which means it's a lookup. Okay, it's going to return some information to you. And our functions are fast. So these, I think every get function we have is order 1. So they're not slow. And then it has, what am I going to pass you? So this entity is, I want something and I want it from this. Okay, so this get num intersection, I'm going to ask you a question about intersections. What am I asking about? I'm asking about the number of street segments. Okay, so that's our convention. Get me some information from this thing, from the intersections, about street segments. And maybe we should have said get intersections num street segment, but we didn't do that. Okay, what we actually are getting is the number of street segments from the intersection. Don't worry if you go, I don't remember that convention, you just read the header file. Okay, everyone's documented. Okay, so this is basically just showing you what I already drew. I've got an intersection, it's got an ID. So let's say this intersection has ID 232. I can, if I ask, get num intersection street segment of 232, right? That intersection, it's going to return 3. It's going to return 3 because only 3 street segments meet at this intersection. It's not a, kind of there's a dead end street there. If those street segments have these 3 IDs, I can get them. Well, how should I get? Maybe it's too hard. I can basically get the IDs of the street segments that hit this intersection by saying get intersection street segment. Okay, so get from intersections. I want to get a street segment. Which one? I want it for intersection 232, and I want the 0th one. So 0th just means tell me the first one. Then I'm also going to call, and that will return 311, right? It'll return this one. I can ask about the index 1, right? Give me the next one. That'll return this one, 321. And I can ask about number 2, okay? Which, because we started at 0, is actually our third street segment. It's going to return this ID. Okay, so I've got the IDs of all 3 of these. What do you think happens if I call this with 3, call it 232? It's good, bad, maybe it's lucky. It's bad, right? So what do you think? It's going to be really bad. Okay, so one of 2 things is going to happen. I believe we actually check and we're going to basically give an error message and kill your program. That's the good answer, right? But what are you doing? We told you there's only 3 things here. The number from 0 to 2. You asked me about 3. Out of range, we kill the program. The bad thing is we don't have that check, in which case, who knows what just happened? You probably just corrupted memory and your program's going crazy. So I'm pretty sure we checked this. I can check our code after. So don't do that, right? Can't go outside bounds. Yeah.
You have like functions that focus on the segments of your second point, or
Yeah, that's this one. Get num intersection street segment. Okay. So for this intersection, it tells me there are 3 of them. And so you need to call that first. Otherwise, you don't know. I know because there are 3 of them, I should go from 0, 1, 2 to get all 3 of them. And I know I shouldn't ask about number 3. I shouldn't ask about number 7 and so on. I know that because I called it first. Does it make sense? Okay. Okay, and then the last thing I could do, so if we call get street segment info of 311, right? That was one of our street segments. We'll get that struct that gives us information about that street segment. Okay, so we can make a few calls and kind of essentially we're letting you walk through this graph. In our API, we have stored this as a graph and we're giving you calls that let you explore it. Okay, so you've already seen this, right? So I already described these functions. I mentioned this in lecture. Basically, because these intersection indexes, street segment indexes, they're all really just typedefs to int. These are to improve readability, but you won't get a compiler error if you just kind of mix them all up, right? You'll just have code that is probably doing nothing good. So name your variables well, keep track of this is an intersection ID, this is a street segment ID, keep track of what everything is, and good variable names help with that a lot. Okay, so we're going to implement this function. So I'm going to give you a few minutes to take a crack at this. Here's, again, what the interface is. We're going to pass you an integer that is an intersection ID. I'm going to give you this, right? You're going to need to make a vector. So here we made an empty vector. Here we return it. You're going to call these functions. You don't need anything else in order to figure out this vector, like fill up this vector, and then it'll be returned. So it'll take a few minutes, and okay, so you have 2 options here. So what most of you probably want to do is, you don't need a fully fleshed out implementation, right? Just open a text editor, take a piece of paper and just say, okay, well, I'm going to do this. I'm going to call this, I'm going to loop over that kind of thing. That's fine, right? So you can just describe to me, this is the basic procedure. If you really want to, you can VNC into the UG machines and try to write it right now. but I'm not gonna give you that long, so it's, you know, probably faster than just say, well, here's the big idea. And then we'll come back to you in a few minutes and we'll see who's figured it out. And to make you motivated, I have a few chocolate bars. If you're a team that goes, I think I got the idea, tell me, I'll call on you and you can earn tasty weekend treats. And I'm going to leave this up because I think it's more useful. This is your library. So all you need are these three functions, right? Call them the right way and you can solve this problem. So let me give you a couple minutes and take a crack at it. And let me hide my floating meeting controls. Okay, so you're saying call this first, get num intersections, street segments. Okay, so you get that many.
And then you just have a STL vector for result.
Okay, so you got an STL vector store the result.
You form the loop from 0 to the number segments by the 1.
Okay, so you're gonna have a for loop. It sounds like you're gonna call this function over and over again in that for loop.
Yeah.
Right?
And push back.
Right. The way to grow a vector, push back. Okay, perfect. Okay, so that's exactly the way I coded it too. So we call this first function, tells us how many street segments there are. We're going to loop through them all. And we're going to basically push each one of them that we get from this second API call into our vector, and then we're going to return that vector. So it's perfect. So you two come get a chocolate bar, whatever you want. Okay, so well done. Okay, so now we're going to test the function. So I'm not actually going to log in and do this because I want to do this fast. But if you have to now build, okay, so type make or build in your IDE. Then you type ece297 exercise 1. And if I only want to run the tests related to intersections, because I know this is the one I'm working on, I could do this. I can say ece297 exercise 1, and I can say run tester. And this basically back quotes with star. This basically is going to match anything with the word intersection in it. So I could just run ece297 exercise 1, but that's going to run all the tests. If I just want to run the ones related to intersections, I could do this. And what I get now is that I failed. And in my particular code, I actually had some other functions written. So I failed 1 of 4. Basically, the functionality one's passed, but the performance one timed out. Okay, so we put a 5-minute time limit on the test. So if you take more than 5 minutes, it just kills your test. We also have tighter time limits on individual functions. So you can also get an error if you take too long. If you take 5 minutes, we just say we're killing your program and you get this timed out message. Okay, so what does that mean? It means you failed performance and we actually failed it by a lot. Okay, we weren't even close because it just said after 5 minutes, I give up. I assume your program is going to take forever. So we're not even close on performance. Does it make sense? Okay, so if we look into m1.h more carefully, you'll see that this has a speed requirement of high, and the definition of speed requirement high is near the top of the file. And it basically says that you need to make this as fast as you can, and we expect you will have to create some data structure and store data in load map in order to make this fast enough. And that's exactly what happened, right? So there's nothing wrong with your code. In fact, you can't make your code any faster. Okay, so that solution is as fast as it gets, given the API that we've given you. Okay, so the only way you can make it faster is you've got to move some of this complexity into load map, and then you can make this function faster. Okay, so the complexity of this, if all of these functions that you called were order 1, the complexity is not that bad, right? It's order k, where k is the number of intersections. So it's not terrible, but it's still not passing the speed tests. Yeah. Pretty much. You're pretty much going to move this code into load map. Now, to move it into load map, I don't know what intersections are. You in load map, you don't know which intersections you're going to be tested on. And our performance test actually, you're going to find often tested on 100,000 cases. Okay, so the functionality we usually test it like 50 or something. Say, okay, you got 50 right, it's probably all correct. For performance, we'll do 100,000. to actually see how fast you are. So yeah, so what are you gonna do? You don't know what intersections we're gonna call you with. So what do you think you have to do? So you gotta brute force it. Okay, so you've got to store enough information you can answer this quickly for any intersection we ask you about. Okay, that's what load map has to do to make this fast. Okay. So load map will give you multiple seconds. Depending on how big the city is, we'll give you more or fewer seconds. Multiple seconds is a lot. Okay, it's enough time that you can go through basically all the data that's in the graph, order n data multiple times. That's fine. If we sometimes find students will write order n squared code, where they're kind of like, okay, for every intersection, let's look at every other intersection. Okay, let's do that next. So we got a loop of all intersections, then we got another loop of all intersections inside that. Okay, that will work. Because that's no longer seconds, that's probably now to be many minutes to hours, right? And we're going to time you out, and you're going to fail that. But if you do things that are order n, even order n log n, 20 order n, it's all fine. Okay, so you got a lot of time to load map. We don't make the load map speed test very high. Very tough. It's just to stop you from doing sort of crazy things. And this is real. I mean, if you think of like a map that people would interact with, you don't want your load time to be forever. People are tolerant and it takes a few seconds for the program to start, but then as it interacts with it all day, or people from outside are querying it, they want it to be fast. So we're moving time from the interaction to the load. Does that make sense? Okay, and in m1.cpp, this is a little skeleton file that we've given you in libstreetmap source. There's a big hint, right? Load your map related data structures here. So we should do that. Okay, so we need to pick. Okay, so we're going to memorize. It's actually given a name too. We're going to memorize this data. We're essentially going to work out all the answers that we're going to store in memory. Now you need to think, is that going to be too much memory? But we're basically, for every intersection, if we stored all the street segments connected to it, that's actually just storing the whole graph, right, in a certain way. It's still just order n. That's not that bad, okay? We obviously, in our APIs, already have the graph stored in the whole thing, like order n already. So it's going to increase our memory footprint some, but it's not going to make it like, go from n to n squared. So it's okay. Does that make sense? Okay, so we need to think, okay, how can we store this? We've got to store it for any intersection. What would be a good way to store this so that we can answer questions really fast? So our input to this function is an integer. It's an intersection ID. Our output, and we know we know something about that intersection, that ID. It goes from 0 to the number of intersections in the city minus 1. Okay, so it's actually like a kind of nice small integer. It's what's called the dense ID space. We actually use all these numbers, they're all consecutive. The output is a vector of street segments. Okay, so that's what we got to return. So you could code this all by hand, but the reason we taught you STLs, you can kind of just think what data structures would be good, and I'll just ask for that data structure. I can code it really fast. So we think, okay, what's our menu? What are our options in standard template library? Well, basically we have a vector, and the way we access things in a vector is by an integer, right? The index. And what can we return? Like what can we store? Well, anything. Vectors are templated, so they could return anything we want. So could we have a vector that actually stores in every entry a vector of street segments? What do you think? So you can, right? You can have a vector of anything, right? So I can have a vector of vectors, perfectly fine, okay? That means every single entry in the vector is itself a vector, totally fine. Okay, so I can do this, and what my code would look like is I would just declare my vector, and if I'm asked a question about number 5, give me the 5th thing, I can return it really fast, right? That 5 is just my index. So what about list? Okay, list can also store anything, right? You can have a list of vectors, it's fine. It doesn't take an input index, right? So we don't have that nice square bracket operator. There is a way to get for example, if I said I want the 5th thing in the list, there's a way to do it. There's a function called advance, which will actually go to the 5th element in the list. How slow do you think that function is? Like in a list, if I ask for the 1,000th thing in the list and I use this advanced function, you think it's fast or slow? It's slow. It's actually order n. It has to walk through 1,000 next pointers. So it is possible for us to write this with a list, but it is a remarkably bad choice, okay? Do not do this. The list is incredibly inappropriate for this. You are better with the code you already wrote. Okay, so this will be, I will store memory to make my store stuff to make my program slower. So this is a really bad choice. Okay, so we have a binary search tree, can store anything, can actually have a key of anything. So could I, and we look things up in a binary search tree with the find call. Could we have a key that is an integer? Yeah, so it'll work. We could do this. And then unordered map, basically the same. Stores anything and we can use any key. So it could also have a key of integer. Okay, so we're going to eliminate list as being totally inappropriate for what we're trying to do here. But the other ones all look like they're possibilities. Yeah.
So, like,
yeah, binary search trees.
So, what would this search tree have log n?
Yeah, it's log in.
Right. And then, when would using a vector like?
Hold that question. Wait till I go through 2 more slides and then see if you still have a question. Okay. So, okay, so we can use any of these to store a vector and access it by this integer ID. Although a list is a remarkably bad choice. We have to kind of write code that you might have to go look up. How do I write this? Probably didn't know about standard advance. You probably don't want to use it because it's going to be super slow. So a list is remarkably bad. Any of them can store a vector at every entry because that's STL, it's templated, can store anything, right? What is the complexity? Okay, so a vector is order 1, right? It's got random access. A list was order n, terrible, do not do it. A map was order log n, and an unordered map is also order 1. Okay, so of this menu, I already crossed off list because it's so bad, right? Anything else you want to cross off? It's not a hard question. Which of these do you think you should cross off next? Right, let's cross off map. It's not terrible, right? It's a lot better than order n, but why would I use it when I've got order 1 choices? It's not going to be any easier to code. So I'm going to cross that off. So I'm left with these 2 choices, both order 1. Okay, so these 2 look from a complexity point of view like they're equivalent. They're not quite equivalent. They're both reasonable choices, but one of them is better than the other. Okay, so in vector and map, order 1 access to get a certain element, right? Indexed by the ID. In a vector, you don't do much. Okay, so in 243, have you learned how you access memory locations? Right, so in a vector, you have inside of it is an array. That array is a pointer. If you want to get to entry 1,000, you just take 1,000 times the size of what I've got, add that to my pointer. That is like a single add, okay? And then you access memory once. That is as fast as it gets. In an unordered map, you first call a hash function. So the hash function's job is basically to scramble the bits. You give me a string, you give me an integer, whatever you give me, I do a bunch of XORs, shifts, and add things together, and I try to get I scramble all the bits, and then I access that entry in my hash table. And that's intended to smear all my data out over the whole hash table, and then it might get conflicts. So sometimes that entry in the hash table is occupied, I need to check for that, I need to move to the next one or do something else. All of that takes time. It's still pretty good. It's order 1, but it is probably 3 times slower than a vector for an integer key like this. So you might be able to pass the speed test with an ordered map, but a better choice for this case is going to be a vector. Okay. So this is something that sometimes students struggle with. Well, they're both order 1, but why should I use one versus another? So let's talk a little more about vectors versus hash tables. Okay, so vectors, again, are just like arrays. They start at 0, they go up to size -1. If your ID space also starts at 0 and goes up to size -1, you cannot beat a vector, okay? It is the fastest data structure you're ever going to get. And a hash table will be, like I said, maybe 3 times slower for that case. So now why then do we have hash tables? Well, what if your input isn't a nice integer like this? What if it's a string? Okay, I can't access a vector by a string, but I can access an unordered map by a string because the hash table takes the string, it smushes all the bits around by XORing and adding, and it finds an index into the hash table. Okay, so that's a good choice for a string. There's another case where a hash table is useful. Let's say I have an integer ID, okay, but my integer ID doesn't start at 0 and go to some number and go to size -1. Instead, it's just a giant integer, okay? A giant integer where most of the values never occur in my data. Okay, and if you think about what we're giving you, there are cases like that. You can't make a vector that big. Okay, so the OSM IDs, for example, are 64-bit integers. You cannot make a vector that is big enough to store 64-bit integers. Well, that has all the entries for 64-bit integers. It's an unimaginably big number. Can't do it. Okay, so so there are cases where you have to use an unordered map, but in the case I just showed you, it's not one of them. Does that make sense? Okay, sounds like you're with me. So I know I'm over time. If you need to go, it's recorded, but I'm almost done. Okay, so how do I do this now? So I need to make a global variable. So I'm making a vector of vectors of street segment indices. The street segment indices is just a synonym for int. I got to give it a name. Global variables should have long names. Do not make global variables that have names SS, okay? Or, ID. That's not good. Like, these are important names. You don't want to conflict with things. So I give it a nice long name, very descriptive. I should probably put a comment on top of it. Didn't bother. And inside load map, I've got to load this data structure up. Okay. So let's just look at what it looks like. Like, what does a vector of vectors look like? Well, the first dimension, so index 0 refers to an entire vector of integers. Index 1 also refers to a different vector of integers. So each of those vectors, I could look inside, and there would be a bunch of integers. Okay, so kind of like a ragged matrix, right? A matrix where the rows don't all have to be the same size. And you can access it just by using the square bracket operator twice. So that's how you can get entries out of this. Okay, so if I take basically intersection street segments of 1, I will get this whole vector. Okay, if I took intersection street segments of 1 and 0, I would get that number. Okay, so it's like a 2D array. Basically, you can use it the same way. Okay, so I'm just gonna I'm not gonna do the breakout. We'll just show you how to write this. So the code to load this up is basically the same as what you already wrote, except you're gonna load it up for every single intersection. So you're gonna wrap a for loop around this. So you're gonna say, I'm basically saying here, make the first dimension of the vector. Okay, so make me a vector of vectors, okay? And the number of vectors I want to be able to store is equal to the number of intersections. So that basically made this first dimension, okay? And every element in that first dimension has an empty vector in it now. And then I go through and I say for every single intersection, okay, I'm going to do the code I just did, right? So for intersection 0, tell me how many street segments there are, tell me what they all are. And I basically say, I want to push back that street segment index that I just got in the appropriate vector. Okay, so I'm using the square bracket operator to get like the 0th vector, and then I'm pushing back all the street segments into it. And then my next iteration through this for loop, I'm going to go through intersection 1. I'm going to ask the same questions. How many street segments do you have? And then I'm going to basically take, okay, for intersection 1, intersection street segments of 1, let's push all those back. I'm going to fill in the second row of my vector of vectors. Does that make sense? Okay. So after I've done this, my find street segments of intersection function becomes very simple. Okay, you pass me intersection 100. I already know the answer. I just return the vector for intersection of 100. That's already my global variable. So it's a one-line answer. So you can't get faster than this. Basically, it just copies, just returns immediately the vector that you already calculated. Okay, so by doing this, we made our function faster. We'll pass all the performance tests. And load map will also be okay because its performance requirement is very loose. You've got several seconds. One of the things you have to think about when you're loading these things is order n storage is fine in load map, right? Even a little more than order n could be okay. If it was order n log n or something like that, it's probably fine, but will be fine. Because we've already stored the whole city. So our API already has order n storage. If you ever did something that's order n squared, it's going to be a problem. But if you think about what we just stored, it's order n. So it's fine. Okay, so that's it for today. Sorry for going over time. Good luck with milestone 1. So.